The mean value theorem, an example. And here, before going through the example, I'll just state, again, we have a theorem. And these theorems, of course, they're true, and they provide some insight into understanding of calculus. Mathematicians get really excited about theorems and use them to prove other things. Most engineers or physicists who would use calculus, they might not even know what the mean value theorem says anymore, although if you explain it to them, they'd say, oh yeah, that's obvious. So it's interesting the role that a theorem plays. Usually the reason that the mean value theorem is stated in this part of a calculus class is not really that you're going to use it to prove anything else so much as it's just good practice for actually taking the derivative. It's just good additional numerical practice. And this is exactly the example of a question that would give you such practice. Find the value of c that satisfies the mean value theorem for the function f of x equals x squared minus 4x plus 5 on the interval from 1 to 5. So the first thing we have to do is evaluate the function at those endpoints. F of 1 equals 2. F of 5 equals 10. Then we need to find the slope. So the slope, this is the slope of the tangent line. The slope of the tangent line is change in y over change in x, which is 10 minus 2 over 5 minus 1. That's 8 over 4, which is 2. So that is the slope of the secant line. Slope of the secant line is definitely 2. And so what the mean value theorem says is that there must be some point on that interval where the tangent line also has a slope of 2. In other words, the tangent line is parallel to the secant line. So we take the derivative. Of course, the derivative is 2x minus 4. And we want to know, can this equal 2? Well, solving, we get 2x equals 6, x equals 3. And so at x equals 3, this is our value of c for this particular instance. When x is 3, the function has a slope of 2, and that is exactly parallel to the slope of the secant line. So that is the value that satisfies the mean value theorem.